So now let's talk about how do earthquakes actually cause their damage. So the first one is going to be from the shaking of the ground. And if you recall that there were different kinds of earthquake waves, so you had the body waves, the primary P waves and secondary S waves, and then you had the Love waves and the Raleigh waves were the surface waves. And so each of those different kinds of waves is going to do something different to the ground. So it could either make the ground go back and forth like this, or it could make it go up and down like this, or it could even be making it go in a circle like this. And you can imagine what that's going to do to a building that's on top of the ground. Okay, another thing that it could do is it could cause a landslide. And so in this picture here, you can see where there used to be a whole lot of dirt and debris that was up on top of a mountain, and it just came sliding down onto that neighborhood there. So landslides, as the kinetic energy of all of this material as it's falling down the mountainside can do a lot of damage when it hits something. Okay, another thing is going to be called liquefaction. And so this is going to be happen whenever you've got soils that have lots of water in them. And then when the earthquake occurs, it's going to vibrate that water so that the soil can actually liquefy. Instead of the soil particles sticking to each other and holding together as a rigid solid, when it's got water in it, then those particles can flow over the tops of each other, and then the ground actually turns into a liquid, even though it's made of soil. And so you can see in the picture there what it did to a building. Buildings can actually sink down into the ground as a result of this liquefaction. Then you got ground rupture. So that's what's going to happen to roads and things as they're moving up and down and sideways. Eventually they're going to reach the point at which they just no longer can withstand those forces, and the ground is going to buckle whenever that happens. All right, then you've got tsunamis. So let's talk about this. In a typical tsunami, one of the results of an earthquake is going to be that the ground is going to lower. So let's say that for some reason, here's the surface of the ground, and this is going to be underwater. So here is the surface of the water, and then for some reason, this thing slides down to here. So this piece of rock breaks loose, and it falls down like that. Okay, when it does that, now look at what's going to happen. All of this water is now going to do something like that, because it's going to fill in this volume down here. And so what this is going to do is it's going to create a tsunami. Now the same thing is going to happen if, on the other hand, if this thing didn't drop down, but this piece up here, if it had moved up, it would have shoved the water up. So either way, you're going to make a tsunami. So a tsunami out in the middle of the ocean, you really are not going to notice it that much. It's going to make a wave that is going to have a wavelength that is very, very large. And so if a tsunami was heading towards you and you are out in the middle of the ocean, you might notice that your boat would go up and then back down again as it went past, but it's not such a big deal. It is a big deal with the tsunami when it starts to approach land. So when it approaches land, it's going to start to feel the bottom of the ocean. And so let's say that here's your wave, it's coming in, and it's deep out here, but then it starts getting shallower and shallower. Well, what's going to happen is the water is going to start to feel the bottom of the ocean, and it's got to go somewhere, so all of that water is being compressed, so it's going to start to build upwards, up and up and up, until it forms a tidal wave. And some of these tsunamis could be up to 100 meters in height. And then whenever that does slosh on shore, it's going to cause a lot of damage. and it's not just going to happen once. So it's going to slosh onto the shore, and then it's going to go back out, and then it's going to come back in, slosh onto the shore, and then it's going to go back out. So every time it does that, it's going to do a little bit more damage. So tsunamis are very dangerous. We have buoys that we have put out in the middle of our oceans that are actually monitoring the ocean waves, and they are there to detect tsunamis. So if there is an earthquake that occurs and we know where the earthquake has happened, we can monitor the ocean waves to see if it's going to be causing a tsunami. So right next to it is a video that you can watch that shows pictures of the tsunami, I believe, that hit Japan. Then another thing that's going to happen as a result of earthquakes is it's going to break gas mains, and then when those gas mains ignite, it's going to cause terrific fires. So that's another danger that earthquakes can do. So how can we predict earthquakes? So we'll talk about that in our next segment.